Hi, it's Richard here from Past That Science. We're going to look at a few transformers today and what they make and look like, what their characteristics are. Just in case you're asked to maybe sketch one, let's have a look at the auto transformer first. The characteristics of an auto transformer are that they have just one winding. You put the winding, you represent it in something like that, like a coil. I know it's badly drawn, but on my trackpad it's quite difficult. That then becomes your primary winding, for which you'll give it the primary voltage. And then your secondary winding, you'll have one common connection, can come off any number of tappings. So this is where your secondary voltage would appear, which is be Vs. Sorry about that, let me just give it a that. I'm only human. So that's where your secondary voltage is, and if you wanted a variety of voltages, you could take lots of different tappings off of this to get a variety of voltages. So that's it. We've got just one winding, a common connection. Then you can have various tappings that would give you different voltages on the secondary side of it. Now there's some major disadvantages of this. One of the disadvantages are that you cannot use this for any degree of electrical separation. So if we're looking for a transformer to give us a SELV, or separated extra low voltage supply, we can't use this transformer. The reason why we can't use this transformer is because the primary circuit here and the secondary circuit, they're connected electrically. But the tappings are taken off that winding, which is connected to the primary circuit, so it doesn't give us any degree of electrical separation. The other downfall of this transformer is that this is where your secondary current would be flowing through this part of the winding, and also it takes the primary current as well. So a lot of current is being passed through your secondary winding, this part here. If after a while, if you put in too much current, you may actually burn this winding out. It may go open circuit and burn out, in which case, unfortunately, it would mean is that the primary voltage is likely to appear straight across the secondary output. Now that's really going to be disastrous. If this was feeding some electrical equipment, for example, then that would be quite disastrous, because it could mean that you're chucking 230 volts straight into a circuit board. Anyway, then, so to recap, the auto transformer has just one winding and with tappings to take various secondary voltages off. You can't use this for electrical separation, and you have to be careful not to burn out the secondary winding, because that means that then the primary voltage would appear at the secondary. Why do they have these transformers? Well, as they've only got one winding, then they're very cheap to manufacture. Well, they don't use so much copper as another sort of transformer, like for example the double wound transformer, which is what we'll look at next. Next then, the double wound transformer. Now generally double wound transformer has some sort of core like this. So if you was asked to draw one, you may want to start with a box in a box to represent the core. And then a double wound transformer, as the name suggests, means you have not one but two windings around the transformer, kind of like that. You can represent it like that. That will then be your primary side, where your primary volts will go in, and then on this side another winding, because this is a double wound transformer. This is your secondary winding. That's where your secondary voltage would come out. And now what we mean by two windings, these are two separate windings in terms of them being electrically separated and physically. Right, they're not part of the same copper. Okay, one will quite often on a core type sit on top of it, or if it's a shell type, it will sit on top of it. But they're separated electrically, and that is why this type of transformer is the sort of transformer that you'll typically find for a self supply or any degree of electrical separation. Current transformers are a completely different animal. They're often used where you've got large amounts of current, say for example for industrial installations, you want to measure the current, or they're used for kind of monitoring devices. If you've got a smart meter, you might have a little kind of clip-on device that clips around the meter tail. That is actually a current transformer. So imagine, if you will, then you've got some kind of really big hefty buzz bars that are carrying a couple of thousand amps. what a CT is, a current transformer, quite often referred to as a donut. It's a device that fits around the conductor, kind of something like this. And that's it, continuing through. So you install it around the conductor. This then has two terminals, which then allow you to connect that to an external ammeter, something like that. So that's the circuit. Why would we have that? Well, imagine if this was literally carrying 1000 amps. To measure the current in a circuit that's carrying 1000 amps is really quite impractical. Okay, the meter would be massive. But what we can do is install a CT, install a current transformer. That might have a ratio of something like, you can get them, 1000 to 5, which means that every amp that's flowing up the conductor will cause no more than 5 amps to flow in the secondary circuit. So 5 amps is a much more manageable current to measure. So we can literally measure 1000 amps with a CT with this sort of arrangement with a lower current that allows us to measure the current quite easily. Now there's a caveat with this, in as much as that this is actually a voltage step-up transformer. Steps up the voltage, so it steps down the current. And for that reason, quite often with CTs, one half of the circuit of a current transformer is quite often earthed. All this is a fairly kind of low resistance path. So if you grabbed hold of any of that, you should be fairly safe and not get a shock because it's earthed at that point. But also it'll have the precaution where it'll have some sort of switch or some sort of shorting link, because the current transformer itself must not be allowed to go open circuit. You may recall an ammeter is a low resistance device, and the upshot is that if you were to take the ammeter out of circuit in order to do maintenance or something like that, you're going to get really high voltages appear at this point. And that could be kind of rather sad in terms of it being a shock risk, and the voltage could eventually damage the insulation of the windings inside the current transformer itself. So for that reason, and well, this goes against a lot of the science, a lot of CTs, they have provision to short out the output of the current transformer in order to maintain a low resistance circuit through it, while then allow you to carry out the maintenance on your ammeter. So you mustn't leave a current transformer open circuit. Okay. Thanks for watching. Now go past that science.